Hi everyone, welcome to my video. Today I'm going to show you how to create a forward and reverse zones on BIND9. This way you will be able to use local domains to manage your local services like web pages, for example, file sharing, authentication, whatever you might need in your company or in your local IT services. Before we start, let me remind you to press the like button and subscribe to the channel. It really helps other people getting to know this video and learning from it. And now, let's do it. Before we start doing anything else, let's quickly install BIND9 because we will need it. And when we start changing our machine, we will lose DNS resolution. So this is really the first step we need to do. Okay, it's done. So let's move on. We need to check the current status of our Ubuntu server. And one thing that we should know is that Ubuntu server, and this one is a clean installation, is using systemd resolved as forwarder. You can check that by making a Google dig. Look here at this IP address. You can see that we are using 127.0.0.53 at port 53, the default port for DNS. If we want to use BIND9, we need to check what we want to use as our forwarder. And it makes sense to use also BIND9 to do it. And for that, we will have to drop systemd. Let me show you the status. Systemd resolved. We need to drop this service. It's running, it's active, and it needs to be shut down. How we do it? First, we can disable it. Okay, we disable it. We can also stop it right away. And if you try to make dig again, you will see that no servers can be reached, which means that we no longer have a forwarder for DNS resolution. Remember that we are preparing our machine for using BIND9. Another thing that we need to check is what do we have in resolved conf. In this file, you can see that we are pointing to the resolver, systemd resolved. This is a dynamic generated file, okay? Do not edit. What we will do is to put it away, okay? I will change the name of the file. So I will move the file to a new name, something like this, old, okay? And I will create quickly a new one, echo name server 127.0.0.1, okay? I just need this directive, resolve.conf will be my destination file, okay? And after we do this, we will block the file, putting mutable flag, making sure that no one can delete it. So I can try to delete it. Okay, operation not permitted. This is a protection not only for me, but also for any service that could delete the file, replacing it by another one. Okay, so of course that by doing this does not immediately allows us to resolve anything, right? So we still have the same problem. Now let's enter bind folder. You can see that we have plenty of files. First file we want to edit is this one, named.conf.options. Let's open it in our text editor. Oh, sorry, mistype. Nano. Okay, so we want to add these directive forwarders and put the forwarder IP addresses we like the most. In this case, I will put Cloudflare and Google, and that's it. Okay, and after we reconfigure, we can restart BIND9. It should work immediately. So if we repeat, it's working properly. Let me just make another one, ubuntu.com, and here we have it. We are making resolutions. One thing that we can notice is that, for example, for Ubuntu, it took us 80 milliseconds to make the resolution. If we repeat the same, it will take 0. This is because we are using local cache to store these answers. Okay, so as a forwarder, BIND9 is already working. Now let's look at the folder again. We can see that we have many files. We will be dealing with local zones, so the files we want to use are named.conf.local. Okay, this is where we will register our new zone, and db.local, and we will be using this file as an example to create our own. So first thing, let's create a new folder called zones. Then let's make a copy of .local to zones, and I will call it db. Let's give it a name. I will call it my.intern. Okay, that's it. Let's edit the zone file. Here we have a standard BIND9 zone file structure. Okay, here we have the time to live. This number is the time that information lasts while it's being cached. Okay, after which it needs to be refreshed by the servers. The @ character is a placeholder for the domain, so this is the start of authority. This is where we put our domain. This is a local domain we are configuring. So this is the email address for management. This is the serial number. This one you should increase every time you make any changes to the zone, okay? So that the DNS servers contacting you can understand when they have to refresh information. The refresh directive means that or specifies the interval before any secondary server understands that it needs to check for any updates to the information. The retry is the directive that defines how long a secondary server should wait before retrying a failed zone transfer attempt from the primary server. So if a secondary server attempts to update its records from the primary server and fails, perhaps, for example, due to a server issue or primary server being temporarily unavailable, it will wait for the period defined by the retry value before trying again. Then we have the expire, and the expire is the maximum time that a secondary server will keep the zone without being able to successfully refresh it from the primary server. So if this time expires, the data is considered no longer valid, okay, and the secondary server will no longer respond to queries for this zone, effectively taking itself offline for that zone. And finally, the negative cache TTL, that means in the context of the start of authority record, it specifies how long DNS resolvers should cache the negative answer when a DNS query fails to find a match. For example, when a query host name does not exist within the zone. The value is used to minimize the load on the DNS servers for queries that repeatedly ask for non-existing records. I'll add the origin variable with our domain, so we can use it as placeholder. Now let's edit the name server of this zone .my.intern. Now let's have our first record, ubuntu.my.intern, for example, should be 10.10.1.1. I will drop this one, something like this, okay? And finally, let's have the IP address of our, this is the second record of our name server, okay? This way everyone will know who to contact when we need to make any resolution regarding the my.intern domain. Now let's save and exit. Leave the folder, okay. Now we will have to edit this one, named.conf.local. So the file is somehow empty. What it means is that we don't have any zone configured here yet. That's what we are about to do. Let me move down. Let's add the zone and open it. Inside we need to type the type of the zone. It's a zone where we are master. We need to give bind the file location, so the file is in /etc/bind/zones/db.my.intern. okay, we finish this, and finally we put the query allowed to anyone requesting it, okay? So allow query anyone making this request should get an answer. Let's save the file, exit, and we are done. We can now restart BIND9, and right after that we can make our first resolution, ubuntu.my.intern. So if we look here at the answer section, we'll see that when we request for a resolution regarding this machine, okay, Ubuntu is the sub domain, my.intern is the domain, and we already got a primary key, an IPv4, so the IP address is 10.10.1.1, okay? So it looks like it is working. We can now move to our client machine. So this is the machine I'll be using. Let me take care of any configurations in the network section before we proceed. Okay, network, wired. So in this case, I need to switch okay, to manual address 10.10.1.2 24 bits mask. Gateway, I don't really need a gateway now, I just need to test, but even though I will put our server as the gateway and as DNS the same. Okay, 10.10.1.1. This is our DNS server for now. Meanwhile, let me change the type of connection in these cards. I will switch it to internal network so that these two machines can see each other and are on the same network. Okay, so let me open console. Okay, API. Here we have the IP address. Let me ping our server. Okay, we are seeing the machine. We have route, and then we can test making the same type of resolution, ubuntu.my.intern, and we should get an answer if everything is okay. Something that needs to be taken care. Okay, I need to allow. Like I said, my server was a clean installation. I can repeat my dig ubuntu.my.intern, and here we have it. So DNS traffic was not passing through the firewall, and that was the reason. It's a clean installation, that's why. So for the same resolution, ubuntu.my.intern, you can see that now we have an answer. IP address is 10.10.1.1. What we can do is to, for example, quickly install Apache 2. Okay, I'll do it so you can see a use case for this quickly. Same thing for HTTP, allowing it on the firewall should be ready. So here, if I open my, let me switch. Okay, I open Firefox. Okay, and I put ubuntu.my.intern. Okay. So as you can see, I just installed Apache 2. I have put the new domain and I'm looking at the default web page. Okay. So at the server side, if I show you the server, TCP dump minus a n minus a n I don't want minus I enp0s 8 port 80, something like this. Okay, let me show you the desktop machine. If I press Ctrl F5, okay, you can see that the traffic is flowing from the server. Let me show you here. From the server to the client, okay? This is the traffic we are generating by opening this web page. Okay, another thing I can show you is DNS traffic, okay? And in my desktop machine, let's clean cache to force it to request resolution again. And then let's make a quick resolution. Dig ubuntu.my.intern, and if I switch to my server, you will see that my client made a DNS resolution using dig command, who is looking for a primary key, who is ubuntu.my.intern, and here is the answer coming from the server to the client. So the primary key for that question is 10.10.1.1. Okay, so this way you can be sure that not only this is the server that is responding, and that for the question you make, you will have an answer to the question. So the domain is working properly. Let's create the reverse zone. So I'll be using this file as a default, and I'll create a new folder, rev zones. I'll copy the file, okay. Okay, so I'll change the name to db 10.10.1. Why? Because this is the subnet we belong to, okay? This zone belongs to this subnet. That's why I've put this file name. Let's edit the file. Okay, so what we need to do is to create the necessary configuration. In this case, we need to tell bind the main name server for this reverse resolution and the corresponding network. So the subnet is 1.10.10. It is written in a reverse way. Internet address ARPA dot. Okay, so this is the first entry. Then we do the same for the specific IP address, like this. And in this case, it's a pointer. Okay. Let me just change. I forgot to put the correct name, and in this case will be Ubuntu .my.intern. Okay, so what this gives us is the name server in the reverse zone, the pointer to the IP we want to resolve, and the same, we should put the same for the name server. Okay, these three are the entries we want for the reverse zone. So let's save and exit. Now in the main folder, I will edit again the file where we enter the zones. Okay, let me quickly copy paste. So the first one is the forward zone. The new entry is the reverse zone. The name needs to be changed, so this now will be 1.10.10.internet address. Okay, so this is the name of our reverse zone. The type is the same, but now the file is in a different place and its name is also different. So it's 10.10.1. This is the configuration we need for this zone. If everything is okay, we should be ready. Okay, let me save and exit. Now let's restart BIND9. Okay, and now we can make a reverse resolution of 10.10.1.1 IP address. And as you can see, when I try to find out the corresponding host name or the IP address that I've got, I will get this answer. Okay, so I found out that there are two possible names that point, okay, to the same IP. So if you got the IP from anywhere in the network, someone was using it, it must be related to either ubuntu.my.intern or ns1.my.intern. This is very typical when you deal with, for example, servers hosting web pages, and when you try to resolve the domain name, you will have the correct server that hosts the web page, but when you try to do the opposite, make a reverse resolution of the server IP, you probably will only get one name, which is the domain of the company that is hosting that server. Okay, not the domain, the specific domain of the web page you were accessing. Okay, so this is the reverse zone already working. Guys, of course, DNS is very complex. There is a huge amount of work that can be done. The main goal of this video was to show you two very simple zones, one forward, one reverse, so you could see and start dealing with BIND9 if you need to create your own local zones. It's very useful because you will be able to use it for your local servers. You can have other types of entries, MX entries for mail server, canonical names, specific configurations using the TXT entry for security purposes. there's many many things to learn around DNS and BIND9 specifically. Of course, there are other options, but this one is a very proven server for DNS. I hope you enjoyed the video. Okay, any questions you might have, please drop in the comment section. Don't forget to press the like button, subscribe to the channel, because it really helps growing the channel and creating the ability for other people to get this video and learn from it. Okay, once again, thanks for your time, and see you next time on my next video. Okay, bye bye guys.